Thanks for coming. My name is Konstantin Gonzalez. I'm a solutions architect out of the AWS Germany organization, and this is Markus Ostertag from our customer team Internet. And today we're going to talk about caching. So our goal today is to help you earn more money and also to save some money so that you can afford your next trip to reInvent next year. And we're going to do this through speed. This session is all about getting more speed into your application. We're going to share some best practices through some architecture patterns. And to make this a little bit more concrete, we have real-world experiences from Markus' company, Team Internet. And as a side effect, you're also going to save some money, and you're going to see in a minute how it works. So this session is the first talk in the EdTech series. Please make sure you check out the other EdTech sessions. They are great sessions, lots of interesting stuff to learn about real-time bidding engines and machine learning for EdTech and all the other stuff. So make sure you check your schedules and go to the other sessions, which are going to be in a different room. So what is EdTech? There's lots of different things going on in EdTech, but on a 10,000-foot level, it's all about connecting publishers with advertisers. And that sort of happens in some form of bidding engine. And bidding is something that is limited in the EdTech business because there's only so much time you can let your customers wait on your website until you decide what ad to give them. So the bidding engine with a limited time creates kind of like a hard cutoff until when your bidding actually needs to have happened, and then you go off and show your ad. And that cutoff is actually something that can happen in a couple of milliseconds. So it is very typical to have just a couple of 100 milliseconds time in which you can have your whole bidding process. And the more you can get done during that hard cutoff time, the more profitable your business is going to be. So it really comes down to having as much speed as possible in your application so you get to get a lot of transactions and do these transactions really, really fast. Now, how do you get to speed, right? How do you improve your speed? There are really three strategies you can follow. One of them is you can increase the rate at which you're running your transactions and minimize the time each transaction takes. And that can become really complex. There's only so much you can optimize out of your application. You can go really down into the nitty-gritty details of your app, trying to increase the rate, but at some level it becomes really complex. Now, the other thing you can do is you can parallelize your application. And parallelization is also something that can turn out to be complex once you go beyond a certain level of parallelization. So the third approach we want to suggest to you is actually the lazy approach. And it turns out that it's also an easy approach. And that is to do less. So in a way, caching is a mechanism for you to do less in your application so that you can get more done in aggregate. So think of caching of ways to save time through doing less, but still being able to accomplish more in terms of transactions. And we're going to show you how this works. So in a way, caching means do the hard stuff that consumes your time only once, and then reuse those results as many times as possible. And the reasoning here is that it turns out that in the cloud and in IT, memory tends to become cheaper and faster than CPU. So if you can get your transaction computed and then you save those results, it's a lot easier to retrieve those results than computing them again. So our talk today is structured around these 4 layers of cake. We structured them into Edge, Web Tier, App Tier, and Database. And each layer in your application offers some great opportunities for you to save time and to become faster through caching. Okay, so this is how most applications look like. In some way, you can relate your application to this diagram. There is some database where all the truth happens. There is your actual application that sits in front of your database and where the transactions happen. Then there is some kind of web layer where you touch the internet with your application. It could be a web server, it could be a load balancer, it could be something else. And then at the edge, this is where the outside internet comes into play, where your actual clients, your users are coming from. And we're going to work from your user back to your database through those 4 layers that I mentioned before. So let's start with edge caching, which is your first opportunity to become faster and add some speed into your application. And the way to do is by using Amazon CloudFront, which is our content delivery network from Amazon. Amazon CloudFront gives you 107 edge locations, and that number is increasing almost every day now, in 55 cities, 24 countries, and it supports both static and dynamic content. So what it does is, it runs a network of proxy servers worldwide that are able to cache your static content, such as HTML pages, images, JavaScript, CSS, that sort of thing. But there's one secret behind CloudFront, and the secret here is that CloudFront can also add a lot of value and a lot of speed to your application, even if it doesn't cache at all. And the reason here is that CloudFront gives you an optimized last-mile delivery mechanism. So think of CloudFront as a network acceleration layer that you can put on top of your application that gives you faster access to your users worldwide. And I still remember almost 5 years ago, sitting in a conference room with Markus Ostertag, now VP of Engineering, and we were debating around CloudFront, and I told Markus, why don't you use CloudFront? And he told me, no, we have nothing to cache here. So here's Markus, and he'll tell you what he did with CloudFront.
Thank you, Konstantin. Yeah, as Konstantin just mentioned, my name is Markus Ostertag. I'm the VP of Engineering at Team Internet. And before I want to start talking about CloudFront and what we're doing with CloudFront, just give you a rough overview about who is Team Internet. We are the leading company in the domain monetization business, so everything around domain parking, buying and selling traffic from the domain parking space. We are only 35 people. Our headquarters is in Munich, Germany, and we are a very, very tech-focused company. So we're always trying to leverage tech as much as possible and trying to squeeze out everything with tech. And so we're trying to be as small on the number of people we're hiring, but leveraging tech as much as possible. We have two main products. One product is called Parking Crew. That's the red logo on the right, which is a domain parking platform, like many of you might already have seen some of our pages, hopefully. And the other project I want to talk about more in detail about today is Tonic. Tonic is a real-time bidding marketplace for this domain traffic. I think many of you are working in the AdTech business, so this should be pretty common to you. We have a user that actually types in the domain name, which is parked with a parking company. Tonic gets a call on a server-to-server basis from the domain parking company. We're trying to figure out which is the highest bidder for exactly that request, delivering back the bid to the parking company, and then the parking company actually sells the traffic to us, hopefully. So the challenges for us when we started with Tonic was that we needed to support clients worldwide. That's pretty obvious, right? We have the need of a latency below 300 milliseconds. I see there are some smiling faces in the audience. I know 300 milliseconds is a lot in the AdTech business, but it's still a challenge, right? And then we have 100% consistency at the database level. So the reason for that is that we're working on a prepaid basis, so our users are actually have some kind of budget or account on our platform, and we only can deliver a bid who actually still has some money in his account. So the questions that arise were, should we go multi-region, or is there an alternative? And just as Konstantin mentioned, when we talked with Konstantin about that, he was like, yeah, maybe you want to do CloudFront. So as we talked, this was the idea we had in mind. This was kind of the architecture. We had Route 53 on top of everything or in front of everything, and then we had the most important regions for us, which is the US, EU, and Asian Pacific. And then, as I said, we have the need of 100% database consistency. So this is where this magic hat comes in, because there needs to be some syncing between different regions to get this consistency. And all of you who might have already thought about building something like that, or actually have built something like that, I'm pretty sure you will say, yeah, that's a complex problem, because master things are working, but they are complex to maintain, they are complex to work with. There is always a bug in it, as always. So as we talked about with Konstantin, he said, maybe you want to do something different. And then, just as Konstantin mentioned, I said, we can't use CloudFront, we don't have anything to cache, because it's a real-time bidding system. What should we cache there? Every answer is different from what we did just a few milliseconds before. But the problem, as Konstantin said, was more about that we don't need to cache anything in CloudFront. It's just about optimizing the latency for our customers. So that is the architecture we're running today. We have CloudFront on top of everything. As Konstantin already mentioned, there are 107 different edge locations. So we're using just all of them automatically because we just click the button of doing it all over the world. And then we're just working out of the US East 1 region. So we only have to maintain one region. We only have to maintain one database in this region, so no master-master sync, no replication problems, no database consistency problems, because we're just using one database or multiple databases, but only in one region. And so this works pretty well for us. We're saving a lot of milliseconds on every single request. And as we all know, everything is about speed. So maybe you just want to try out, even with a TTL of 0, CloudFront might help you to just get a little bit faster than you are right now. But CloudFront can do a lot of more things besides optimizing the last mile. And now Konstantin will talk a little bit about Lambda Edge.
Thank you. So CloudFront can help you with caching, and even if you think you can't cache, second use case would be network acceleration. And here's the third thing you can do with CloudFront. Because since last year, we introduced Lambda at the edge, which means you can actually modify content at the edge layer as it is flowing through the CloudFront network. And there are actually 4 bits where you can do that. The first is when the end user issues an HTTP request against the CloudFront cache, you can run your own Lambda code and do something there. You can modify the viewer request. And as the request maybe is cannot be fulfilled by the CloudFront cache, you get the second chance to modify the request as it goes from CloudFront to your origin in your backend. And as you deliver your content, you can run your third Lambda function to modify the origin response. And then right before your response reaches your user from the cache, there's a 4th opportunity where you can run your Lambda code. So it means that you now get to execute your code right in front of your user at the edge layer of your application worldwide. And there are a couple of interesting use cases where you can leverage that. The first one is you can do content customization at the edge. So that means that as your content is being delivered right to your user, you can have a last minute or last second or last millisecond change in the kind of content you deliver. For instance, if you want to optimize for mobile devices or if you want to do something else. The other thing you can do is you can do visitor validation. You can fail a lot faster if your visitor gives you the wrong API call, because it doesn't have to wait until it goes to the backend and then your backend figures out, wait a moment, this is not a valid call, let's give him an error message. You can do that error checking at the edge and then load off of your backend here. And the third thing you can do is you can use it for A/B testing. You can use the CloudFront Edge layer with your Lambda functions to differentiate between A and B groups in your A/B testing and do this really, really fast in a way so that A/B testing doesn't affect the speed of your application. So let's do a quick recap here about edge caching. You can use CloudFront to reduce your last mile latency. You can leverage caching or not. Doesn't matter. You will always get a benefit out of CloudFront if you put it in front of your application. I have a hard time figuring out a scenario where CloudFront would not add any value. So try it out and see if it helps you in your latency or in your caching needs here. The other thing is you can save cost with CloudFront too, because gigabytes delivered over CloudFront are cheaper than gigabytes delivered without CloudFront through the normal IP address or through the normal region networking. So even if it doesn't help you a lot with latency, which I would doubt, it really helps with your build too. And the other thing is you can now use Lambda at the edge to bring your code, your logic, closer to your applications, or sorry, closer to your users. So let's move on to the next tier, and that is the web tier. This is kind of like the edge of your actual application in the cloud. This is the bit where you deliver your content to your user. And in web tier caching, what we do here is we introduce an extra layer between the web tier and your application tier here. And there's a lot of opportunities here to cache something even before it reaches the CloudFront cache. Now, some people would say, wait a minute, why do I need another cache here? I'm already caching at the CloudFront layer, right? Well, if you're caching on a content delivery network like CloudFront, that's fine, but a lot of those requests are going to be forwarded back to your backend because they are not cached there, because they're original requests or something like that. And this is where you can have a bigger impact by deciding what to cache up front as part of your web caching tier. There are some popular solutions based on Varnish, Nginx, or even an Apache module, Squid, what have it. All of them work similarly. And the key thing here is to try to cache your HTTP response in memory, as it is already done, to avoid crafting it from scratch. So instead of really going through all the motions to deliver that HTTP response, you can cache it at the web layer. And that means that you should take a look at your instances and favor those that have more memory, like the R4 family. If you don't want to go through the trouble of modifying your existing application, you can use a neat trick here, because you can use the API gateway, which gives you an in-memory cache right at the layer. So on top of the normal caching layer that CloudFront would give you, you can add an in-memory cache right as part of the API gateway. And you can forget about everything else on this slide and just think of API gateway as an opportunity for you to add a simple in-memory cache on top of your HTTP stack. So one of the things customers ask, okay, I get it, let's do caching. What are the best practices here? And the thing is, you can cache all of the static content already. You can put all of those images, HTTP stuff, in memory versus on disk and get some extra latency that you can save there, or save some extra latency. You can even cache logged out users. If you know that user is logged out, your application is going to follow a different path. And having the information there already that he's logged out, that you need to ask him again for authentication or something like that, is a valuable information that you can cache, and that helps you save on your applications. The other thing is, you should look into your log files and try to identify those HTTP requests that are really, really frequent and that you want to cache up front. So this is kind of like active caching. If you know that these users are going to deliver a lot of traffic, why not cache them up front so that you can deliver that response a lot faster? And when caching, when you think about your caching strategy, and we're going to dive deeper on this in a couple of slides, choose your TTLs, because whenever you choose to cache something, you need to choose when to invalidate that information. And if you choose a time to live that is too long, then you may see some crazy stuff after every deployment, because then you're going to work with old data and it'll confuse you. So make sure that you have some sort of invalidation strategy here. But even if you decide to use a really, really small TTL, just a couple of seconds, you will see in your log files that it really helps save a lot of time in aggregate. So let's recap on the web caching stuff, and we're going to repeat and go deeper into some of these issues in a couple of slides here. But on the web caching, it pays off to have an extra cache between your content delivery network and your application. Amazon API Gateway can give you an easy way to add an extra cache layer on top of your application without having to run all these extra servers. And make sure that you understand your caching strategy here. What do you cache, and how long is your time to live here? Okay, let's move on to the core of your application, or the first half of your core, which is the app tier. So your application is sitting on a bunch of EC2 servers, and we're now talking about how can you add value by putting a cache on top of that and help you save time here. And if there's one thing that you take away from this talk here is you can really cache everything. You can cache your sessions, you can cache your results, you can cache aggregations that you put together out of different database connections and cache them. You can even cache your templates. Even though they are sitting there already pre-computed on disk, there's a lot of value in having them in memory versus on disk. So you can even cache your static content within your application, even if they are cached somewhere else. You can cache your environments. You can cache your configurations file. There is nothing you cannot cache, and you'll see in a minute that it makes sense to cache everything in memory as fast as possible. Because everything counts, right? So who knows Depeche Mode? I'm an old guy, I know. And I'm from Europe, so. So here's a Depeche Mode song called Everything Counts in Large Amounts. And nothing is truer than in caching in EdTech. Because many EdTech applications see tenths of thousands or even hundreds of thousands of requests per second. And that means even if you can shave off a microsecond or a millisecond in the latency of your application, they will add up big time. So let's take a simple calculation. Let's assume that you can save 1 millisecond out of every transaction through some form of caching or optimization. And if your application is delivering 10,000 requests per second, let's add up the numbers. And you don't need to pull out your calculators here or mobile phones. I did the numbers for you. It all adds up to more than 7,000 instance hours per month that are saved, that you don't have to deliver your application from. This is not just saving money because you don't have to run all of these EC2 instances. This also saves a lot in user experience. It makes your user experience in aggregate that much better so that you will see a lot more people. So it really pays off to be super nerdy here and try to shave off as many milliseconds out of your application, because every millisecond is going to multiply it 10,000-fold in your typical application. So the next logical question is, how do I find those milliseconds that I want to optimize for? And that is where logging and monitoring comes into play. So let's hear from Markus how he's really good, how he is dominating monitoring at Team Internet.
Okay, now you set the expectations, right? So as Konstantin said, it's important to know what you can cache and how you can cache. And in the end, it's always about trying things out. The problem is, if you try things out and you don't monitor those things, you don't learn anything, right? So what you're seeing here is a part of one of our dashboards we are having. This is one of our Datadog dashboards. We're pushing a lot of data to them and then trying to figure out how we can optimize our caching. I just want to give you an overview or an idea about what kind of metrics we are caching, so that you might be able to adapt that to your application, or might find some ideas appealing that you might want to try out inside of your application. What you can see here is each row is an own cache inside of its own business domain. So for us, it's, for example, we are caching domains, we are caching advertisers, we are caching budgets, we're actually caching everything. And for each of those caches, we have 3 main metrics. And that's what you're seeing in the columns. On the left side, you're seeing the so-called unique keys seen. That means how big is that dimension? So how many different values have we seen in a time frame, like a second or 5 seconds or 10 seconds? This is important for the caching because the bigger the dimension, so the more values we're actually seeing in that time frame, the bigger the memory consume of this cache will be. Because obviously, if we're caching everything that comes in for different values, that will add up inside of the memory. So that's why this number is very important for us. Then in the middle column, you're seeing the percentage of the hit ratio. The dark blue part of the bars are the hits, and the light blue part of the bars are the misses. You can see in the first row that this cache is something working like 50 to 60% of a hit ratio, which is okay. And then you see in the second and the third row, those are pretty good. I think the people in the front row will see that there is a small line of light blue at the last row, so those caches are working at 98 to 99% of a cache hit ratio, which is awesome. So this is exactly what you want to have, right? And then we have another metric, which is also telling us something about hits and misses, but the absolute numbers. So every request we're doing against our cache, we're actually pushing a metric if was this one request a hit or was it a miss. This gives us an idea compared to the percentage that are we increasing or decreasing the overall volume of requests we're doing against our caches. This is obviously important if we correlate that to the overall requests we're seeing, because sometimes we see a peak in the requests, but we don't see a peak inside of the cache requests. That's because sometimes you don't need all the caches you're having for the requests because you're answering the requests or you're blocking requests before they even hit the caches. And this is very important to know which are the caches I still need to answer or I still need to ask, even if I'm blocking requests or not. Because that obviously gives you an idea about what caches need to be very flexible in scaling in and scaling out, what caches can be more stable and be more settled, and this gives you an idea about how you want to build your caches. So as I said, it's everything about trying things out. So sometimes you build something in your application, you monitor things for, depending on how much requests you're seeing, minutes, hours, days, or even weeks, to find out based on that metrics to see, is that something I want to work on or even more want to work on because it seems to work, but I need to tweak some things, or is that something that was just a stupid idea? So if you have this metrics now, you actually can do something which is influenced, I would say, by Vincenzo Pareto. How many of you know about the Pareto Principle? That's good. For all the others, but the Pareto Principle is about that there is always a small percentage, or most likely, a small percentage of sources or kind of impact sources that do a huge impact on your overall system. So that's why it's called most of the time the 80-20 principle. Because you will find heavy hitters. Those might be some publishers that are sending requests to you. That also might be some advertisers that are buying a lot from you. Those might be some things like I'm seeing much traffic from the US, but not so much, for example, from South Africa or something like that. You need to find those heavy hitters, those very few sources that make a huge impact on your system. Because if you found them, you can do special things for them. And I really mean things like, I want to do a total different caching type for you. I want to keep those things in memory on the application instance and not doing something like an external cache or something. So if you're able to find those heavy hitters, you can adapt to that inside of your application, inside of your caching. And you will make a huge impact out of it, because even if you do that for a very small percentage, it will have a huge impact on your overall system. And talking so much about memory and caching in memory, Konstantin now will talk a lot more about memory and what we can do with memory.
Thank you, Markus. So we're in Las Vegas, right? So if you walk down the casino, you will see those heavy hitters, because these are the people who throw a lot of money around. And they get special tickets to shows, they get special rooms, they get all kinds of special treatment. So try to find your special guests, and your special treatment to them is give them RAM as much as possible. And if you look at your existing machines, and thanks to Markus, you know you should be monitoring RAM usage, how much RAM is actually used in your applications. And if you're not using close to 100% of your RAM, you have a caching opportunity there already. So use the RAM that you already have, even if it means duplicating data. If you find those heavy hitters and you have their records always present on RAM in every single instance, doesn't matter where they show up, you will be able to service them immediately. Don't need to ask another machine, because duplicate data is good if it helps you achieve speed. And that means that you can also preload popular data into your cache. Not just cache the stuff that you already did, you can use the time that you're idling for pre-computing data that can help your future customers and have them in RAM always ready to use. Some operating systems come with a file system cache. I'm just assuming that yours does. But if you're programming in a specific language like PHP or Java or .NET or whatever, there is always a caching framework you can use to leverage that RAM inside your machines. So what do you do if you don't have enough RAM on your application servers? You can add more RAM with Amazon ElastiCache, which is basically RAM as a service. It helps you manage a fleet of machines that are nothing but RAM as a service and be part of your application as an extra RAM-based caching layer. It comes with two engines, a Redis-based engine and a Memcached-based engine. And both of these engines are great. They're just different use cases that you might want to look at to choose the right engine for you. So Memcached is the easy option. It's fast, it's open source, but it doesn't offer any kind of persistence. But it's a nice workhorse for caching everything on some caching server like Amazon ElastiCache. If you want to be more fancy around your caching, we would suggest taking a look at Redis. Redis comes with a lot more features. It also offers a persistency scheme. So if the caching nodes go down, there are some mechanisms you can use to have your cached content always available, highly available. And it also comes with a scripting language that you can use to offload some of the computations right at the cache level, which can help you increase even more your performance and be more sophisticated here. So it's a good idea to check it out. And it's also even faster than Memcached in many, many cases. So let's recap the app side before we move on to the core of the application. So the thing here is really monitor everything. Only if you can see your requests, you will be able to make out those opportunities where you can increase speed in your application by caching the right stuff. Try to find those heavy hitters, the big people, the big customers that are dominating your application usage, and do whatever it takes to make them as fast as possible, because that will benefit all of the other users of your application as well. Cache everything. There's nothing you cannot cache, and if you cache something, just cache in RAM. There's no value in caching something on disk. RAM is always going to be faster than disk, so use that RAM, and consider using something like ElastiCache to add more RAM on top of your application tier. So let's move on to the core of everything, which is the database. This is where the truth of your application resides. And similarly to how you would place a cache on top of your application, you can place a cache in between your database and your application. And it's a little bit unintuitive because we have an extra piece of architecture between the database and the application. And ironically, it is going to help you increase the performance and decrease the latency, even though it's an extra piece in the puzzle here, and it adds an extra link to our chain. But we'll see in a minute how fast it can be. And this is where most of Markus's work of the last couple of years is coming from, because he has really optimized caching all the way through to the database here.
Thanks again, Konstantin. Yeah, I think when you actually signed up for that talk, you might have think about database caching, right? Because this is where everybody focuses on. And as Konstantin said, I think it's also the most important part. That's why I love this part the most in the talk. As you can see in the in this slide, caching the traditional way. We have an application that is directly talking to databases. I just took DynamoDB and Amazon RDS here as an example. And then we put something in between, like ElastiCache, also just mentioned by Konstantin. If we can't do that on our application service in RAM, we should buy our external RAM, and that's ElastiCache. But then we always come to the point where we need to think about cache invalidation. And there is this very famous quote from Phil Carlton: there are only two hard things in computer science, cache invalidation and naming things. And we all know how hard it is if the variable should be named foo or bar, right? So the other thing is cache invalidation. For me, there are two ways how we can cache. One is the typical cache invalidation with a time to live. So you have a TTL on the key that says, please just live for 60 seconds or leave until this timestamp occurs. And then the caching engine, like Redis or Memcached or whatever caching we're using, is invalidating that value. And from there on, it answers with an I don't have anything in here which is cached. The problem that arises is if we take the TTL very, very low, we obviously are not so efficient on the cache hit ratio, because the cache invalidation will lead to more and more invalidations if the TTL is very low, and then we need to ask our databases again, which is exactly what we actually don't want to. But if we do a very long time to live, we have the problem that if something changes inside of our backend database, we get not the right answer because the cache has an old answer still saved, and that will be saved for a long time because our TTL is very long. So the other way of how we can cache is keep the cache in sync all the time. Because if we always know that the cache answers always with the same answer than the database would do, then we don't need to take care about the TTL anymore, right? How we can do that? Synchronous writes. Our application can actually write for every update or write to the database, not only to the backend database, in this case, just as an example, DynamoDB, but also to the cache. So every time we write against DynamoDB, we also write against Redis or Memcached, for example. This works, but it needs a huge change inside of our application. The benefit we get out of this is that some databases, for example, DynamoDB and Redis, give us a so-called after-write return value. So I just want to show you a little bit of code. The most important part here is the orange one. That's a call against DynamoDB. You can see, for those who don't know, that's JavaScript, so Node.js. And the return value is updated new, tells DynamoDB that after DynamoDB did the write, it should give us back the value which is now inside of DynamoDB for exactly that object or that item. We now can do exactly the same with Redis. That's the black part. Redis does exactly the same. We do an increment by float on Redis, we update a value, and Redis gives us back the value which is inside of Redis now after we wrote that. The orange part, now most of you will see that's Node.js. We do both calls in parallel. So we do the DynamoDB call and we do the Redis call in parallel. And then the if clause says, hey, now compare those two values. The reason why we're doing that, and that's actually really a part out of our application, we now can monitor if our cache is running out of sync for whatever reason. We can either do something against it, like invalidating the cache right away, because obviously now our cache delivers wrong answers, which is bad. We can invalidate it, so on the next call, the cache will be updated automatically. Or we can just alert on that somebody looks after it. Or we can just do nothing, because it's totally fine or whatever. So this is not about what we can do, it's more about how we can recognize that our cache is running out of sync. But most of you now will say, it's nice, but I don't want to change my application that much. Lucky us, we are running in AWS, and AWS has always a workaround where we don't need to do those heavy lifting things. We can use AWS services. For example, if you're working with DynamoDB or Amazon Aurora, there is a DynamoDB stream or a so-called stored procedure which can trigger a Lambda function. So why not let the Lambda function do the update inside of my cache? So I don't need to do that in my own application, because now the Lambda function makes sure that the recently updated item or row inside of my database gets also updated inside of my Redis or inside of my cache. This is uncoupled. This has nothing to do with my application. My application still can write and update always against the backend database, but it can read all the time from the cache, because it can be sure that the value inside of the cache is updated. The downside of this approach is there is a small delay for cache updates. That's pretty obvious, because Lambda, the trigger of Lambda and Lambda itself needs some time. But this will be below, that's what we are seeing, below a second. So if you're right now working with a TTL, for example, of 10 seconds, this is still way better, because this works within a second and not within the 10 seconds you might deliver a wrong answer based on your TTL. But we don't want to care at all about caching. And this is where a new service from Amazon comes in. I think it was launched 6 months ago, something like that, which is called Amazon DynamoDB Accelerator, short DAX. And the idea behind this is that we as a customer don't need to take care about the caching at all. We just talk to DAX all the time. The benefit for us as a customer is that there are SDKs out there for Java and JavaScript right now that are DynamoDB API compatible. That means we don't need to change our application. We just need to switch over, as you can see in the light blue code here. What we had was a DynamoDB client, and now we're just using the Amazon DAX client. From there on, we can do our get item, put item, whatever we did against DynamoDB, we do that now against DAX. And DAX is taking care of caching the things, saving the things, taking care about the TTL, all this kind of stuff. So it's actually a write-through cache. So we're just talking against the cache all the time and don't care anymore about what the backend database, DynamoDB in this case, needs to be updated, all this kind of stuff that's taken away from us as a customer. You can do multiple tables with one DAX cluster. So even if you're running multiple hundreds of DynamoDB tables, you actually can use just one DAX cluster, which is based on sharding, and you could do multiple nodes inside of the DAX cluster. As we're talking in the AdTech track, speed is everything, we said it. We did some performance testing of DAX. Without DAX, you can see on the left, we're talking of an average, so talking about DynamoDB directly, we're talking about an average of 5 to 6 milliseconds, which is still pretty good, right? We have a consistent performance. We obviously have no warming phase because we're talking about our backend database. And we have detailed metrics per request, which is cool. With DAX, we're talking about an average of 400 to 450 microseconds. So only a tenth of what we're seeing with DynamoDB directly. We have a very consistent performance, around this 50 microseconds. Obviously, we have a warming phase because now we're talking to a cache. But what we've seen in our application was that even on cold keys, the average is below what we're seeing on average against DynamoDB. My assumption is that the reason for that is that our connection handling to DynamoDB out of our application is not so efficient what the DAX team can do while talking to DynamoDB. So latency is everything, and every time we need to wake up the connection or build up a connection, that takes time. Obviously, the DAX cluster does a better job than we do. Right now, we don't have metrics on request on the DAX, but you get a lot of metrics like the cache hit ratio and all this kind of stuff out of CloudWatch with typical delay of CloudWatch, so still pretty good. Talking so much about caching and talking so much about everything. We say cache everything, do all the things in everything. So cache everything sometimes has, what should I say? Cache everything sometimes means that you might forget something. And we did exactly that. We forgot about something. We forgot about negative caching. When we built up one of our biggest caches, we had the problem of sometimes, or actually unfortunately many times, our DynamoDB answers with a no result. And that's totally valid. Because in many times, if we're asking our DynamoDB, hey, give me the highest bid for this specific targeting options, DynamoDB says, I don't have a bid. And that's totally fine. It's also an answer. The problem was in our application, we had something like, if DynamoDB answers, then save that to the cache. But DynamoDB had no results. So we didn't save something to the cache. And so for the same targeting options, we again did the request against DynamoDB. And that's what you can see on the slide now. Because without negative caching, so without not saving that valuable information of DynamoDB has no result for this specific query, we had a cache hit ratio of 25 to 30%. And then we implemented the really simple thing of, hey, with this question, DynamoDB has no result to our Redis cache. And with negative caching, our cache hit ratio went up to 89 to 95%. So a huge increase in the cache hit ratio, which actually means that we don't need to ask our DynamoDB that often, which obviously means we are faster, because our cache answers a lot faster than DynamoDB, and we save a lot of money because we pay DynamoDB on the provision throughput. So think about that when you're thinking about what can you cache, that even if in a no result, there is valuable information in it, because you don't want to query your backend database for the same query over and over again just to get the same answer. You can save the answer, even if it's a no answer, to the cache. So let's wrap up the database caching thing. Cache everything, even the negative results, just as I said. I think that's the most important part. We learned a lot out of that, and we saved a lot of money while we were learning that. Consider the cache auto update with Lambda for those that might be suitable. You can combine application with database cache because Konstantin said it, Redis, Memcache are a good solution. Redis, Memcache are also a good solution for database caching. So you can use actually the same database cluster, the same caching cluster if you want to. And I highly encourage you, if you're able to use DAX, because DAX is an awesome service which takes a lot of pain of the whole maintenance away from us as a customer, and it just works out of the box and delivers awesome results. So now we have all the tiers, and I think Konstantin will wrap up the whole talk.
Cool. So this is the recap after the recap. As you go out of this talk and hit lunch and the rest of reInvent, it's easy to forget some stuff. So maybe you should pull out your phone and take away some 2 or 3 things you want to do on your application. So who's using CloudFront already? So let's have a quick talk. OK. If you didn't raise your hand, check it out. It can deliver value to you even though you think there is nothing to cache. Monitor everything. Who is monitoring really everything? Oh, some really good tips. If you didn't raise your hand, just write down monitor everything. This is where you find your opportunities to cache and see where your opportunities are. And they will likely end up in the top 20% of your users, and you want to do something really special for them, which will have a huge impact on the rest of your application. Consider adding a web cache. Even if you're using CloudFront already, it can pay off to have another cache between your app and your web cache and the CloudFront. If you're not caching at the app layer, who's using ElastiCache already? OK, if you didn't raise your hand, check it out. It can add value to your application and explore what you can cache. And remember that song, everything counts in large amounts. And even if you can save a millisecond of your transaction, it will add up big time. And as you can see, using DAX, it can be easy to save 4 or 5 whole milliseconds just by using DAX in front of DynamoDB. And that's mind-blowing, because you can then, for your 10,000 requests per second app, you can multiply that by 10,000, and you can save thousands of dollars. And more importantly, you will be those milliseconds faster for every transaction, and that will give your users a better user experience. It will give you more time to run those real-time bidding options and find those better users and create more value. So cache everything. And with that, I hope you get a lot of speed out of this talk. And we still have 10 minutes or so for questions. Thank you very much. Thank you. We do have a couple of mics up there. Feel free to walk up to a mic and ask your question.
Hello. In your architecture diagram, when you went from 3 regions to 1 region, and 3 databases to 1 database, what strategies did you use to mitigate that database as a single point of failure?
Actually, as we're working mostly with DynamoDB, AWS takes care of that. Obviously, if DynamoDB is going down in the whole region, we will have a problem. But what we're doing, we're actually replicating on our own system to another region, which is kind of a cold standby. So we have everything in another region, and then that's just something you need to commit to. That if the whole region is going down, you will go down. Right. If you're not OK with that, then obviously you should do still the multi-region setup. But if you're having something like, OK, I'm OK with that I need to manually migrate over, if you're working with CloudFormation or so, that's pretty simple. Yep. You can migrate over the whole architecture to another region, spin up everything there, because the data is already there if you make sure of that. Does that answer your question?
Yes, thank you.
And remember, DynamoDB already works out of 3 different availability zones. These are 3 different data centers that have non-correlated risks. And I work with a lot of enterprise customers. They are very happy if they are sitting in 1 data center and they have a disaster recovery solution in a 2nd data center. And with DynamoDB, you get a fault-tolerant database that is already running out of 3 data centers. So having having a disaster recovery solution in a 2nd region is something that typical enterprise customers dream of. So this is already a lot better than the usual setup. Next question.
So for database caching, you mentioned 3 options: using DAX, changing your application so that it talks to either the ElastiCache or the database, or making a Lambda function. Do you have any criteria for how you decide which one of those is going to be the best solution?
Try it out and monitor everything. That was the obvious answer, right? Actually, we figure out based on the business domain what the cache is working in. So sometimes we are more happy to change the application and actually monitoring if we're running out of sync. I don't think there is a rule of thumb. You need to find out on your own what works best for you. If you are okay with the delay of this 1 or 2 seconds, the asynchronous way is more on an architecture level than actually building something in your application, which might be hard. So it might be easier to add something to the overall architecture on the AWS side than rebuild something inside of your application. Then obviously, this might be the good choice. But changing from DynamoDB to the DAX way is really very, very simple and easy. So if you have, I think it's right now, Java and JavaScript are the SDKs that are available right now. So if you have an application that is working with Java and JavaScript, I highly encourage you just to try that out, because it's a very easy fix inside of your application, which gives you a lot of things coming from AWS at that point. So my approach would always be thinking about DAX first, then seeing if I can work with the asynchronous way, with the Lambda thing, and then go back to rebuilding something inside of my application, because that's most of the time the biggest pain, right?
By the way, for those people who are still sitting here, thanks for sitting here. There's a quick plug here. If you like this talk, and since you're sitting here, you seem to have liked it, there's another talk by Markus and me. We're going to dive deeper into how to save money in the ATC303 Running Lean Architectures talk tomorrow. So feel free to drop in, and we're going to go into a lot of detail into money-saving tips there. We still have some time left. Next question, please.
Hey, how do you handle, or have you approached, how do you approach handling the issue of cache coherence between the layers? Because that's kind of the third hard problem.
Right. Yeah. Cache coherence between layers is a hard problem. You need to understand your application, and you need to do trade-offs about how old an information you're capable of dealing with. Sometimes it's okay to work with old information for the sake of better performance. Sometimes it's not okay. And this is where you get to choose your TTL logic, and where you need to do a smart decision here how your TTL is going. If it becomes critical to always have the latest data no matter what, this is where you want to be closer to the database, and where you want to have a tactic where the cache is updated at the same time as your database. And this is probably one of the other criteria for the previous question on how to choose which strategy to employ at the database level.
Yeah, but what I mean, when you do that, you can immediately update the database level cache, but you have in application, in-memory application caches, you need to invalidate those as well. And
that's right.
And if you have CloudFront, you have to invalidate CloudFront too.
No, you don't have to invalidate CloudFront. CloudFront actually asks, you can actually configure a TTL of 0 with CloudFront, and then CloudFront will simply issue an HTTP head request to the origin and ask, has this content changed? And it is a lot cheaper to answer to CloudFront, no, this has not changed. You can feel free to use your cached copy, and you will save something, even in the event where you give CloudFront a TTL of 0. So for these types of data, feel free to give CloudFront a TTL of 0. CloudFront will still be able to cache content, but it will use those head requests to verify that it still is working on current data. And you can have a similar protocol between the application layer or the database layer, or you can merge the application cache with the database cache into the same memcached instance and kind of like work together. Again, it is use case specific. For CloudFront, you can use the HTTP head protocol there, which saves a lot of bandwidth, especially for images and stuff. And yes, this is where you become a lot more geeky in understanding where the trade-offs are.
One thing I want to jump in here, what we're doing is we're actually thinking about the more control we have about the cache itself, the higher the TTL can be. That's kind of our rule of thumb. So actually, we don't control the cache of CloudFront because that's total AWS, but we have 100% control about what we are keeping in memory in our application. So I can invalidate those things in memory on my application server within microseconds. So that gives me a huge opportunity to increase my TTL, because I know if I want to invalidate it, I can do it right away. With CloudFront, I can't do that right away because that's not something I built inside of my application. So I need to figure out what seems to be the right TTL. And we, in our application, tend to have a lower TTL for those caches we don't control that much than what we control on our own Redis, for example, but also in our own memory. Maybe that helps.
And that's another great reason to have your own web cache on top of your application, but before CloudFront, because then you can give CloudFront a TTL of 0 and have that decision whether it's still valid or not under your control within your application.
Thanks. Yeah.
Thank you.
Thanks for the talk. I have a question about how do you cache the transaction data like the budget of the advertiser?
Sorry, I didn't get that last part. The transition, what caching?
Transactional data like the budget of advertiser.
Okay, the what of the advertiser? Sorry.
Budget.
The budget?
The budget. Ah, okay.
We're having that in Redis. And what we're doing, so we update everything in Redis, and then in kind of a, let's call it a cron job. Several times a day, we're actually updating the budget from the Redis back to our, in our case, Amazon Aurora or Amazon DynamoDB. So we are not really afraid of losing something in there, even if Redis is not highly durable. But we're totally OK of losing something like the last 5 or 10 minutes. That's kind of the risk approach you need to do there. And so every 5 or 10 minutes, we're saving everything back to our DynamoDB, which is then kind of the backend database, which is highly durable, and nothing happens in there. Does that answer your question?
But the key problem is that you need to know you deliver some you deliver some ads, then you need to minus the budget. You need to do the calculation, and those happens time by time, right?
Yeah, but Redis does all, as we're working just in one region, that's the benefit of working just in one region, you can increment and decrement by float inside of Redis in an atomic way.
Okay.
So, and then we get the right back return. So we can't do something like, hey, please decrease, or actually increase with a -4 sign. So decrease the budget and give me the answer which is done after the decrease. As that's atomic, we know exactly that's the right budget we have for this advertiser right now.
Okay, thank you.
Last 2 minutes for questions, and already thank you. Please remember to rate this session. We would like to be back here next year. So let's have the last question here now.
Do you have any solution about expiring data, especially in the S3? I mean, when I write the data, it immediately knows when the data should be expired.
So when you mean keeping a tab on when is the data, when was the last update, and when did the previous one expired, right?
Yeah, maybe.
You can build a hash table on DynamoDB to have that information ready, and then have S3 as the lazy part of that layer. That's one strategy you can have here, which means that the source of truth about the updates is in DynamoDB, but the actual data is, or the blobs are on S3. That's one strategy here.
Yeah, actually using something like DynamoDB as a metadata storage.
Right.
So you're building something like a metadata storage in whatever database you want to have it, which you then can update, and then you have kind of a pointer or a link to the S3 object. But I think it didn't work right out of the box in S3, so it's always that you need to create something like a metadata.
Right. The other strategy you can have is, if you're using CloudFront, you can issue version numbers as part of your URL. That means if you update the data, you update the URL with a different URL, which means that it's guaranteed that CloudFront will not have that one in its cache, and it will always be forced to fetch it from the origin because it encounters a new URL. So as your application generates a new URL with the more recent version of the data, CloudFront will be guaranteed to go back to your origin to get that latest revision without needing to issue a special invalidation call, which takes time and effort and is not under your control. So by giving out unique URLs for each new version of the data, you can have a consistency right through the whole chain through CloudFront.
Okay, thank you.
You're welcome. So thanks a lot for coming here. Enjoy the rest of reInvent, and thank you.